write HTML code, and you can understand Finnish so much, but you can translate the questions in English or in Russian or in Spanish or French or whatever languages our Moodle offers. Send me email and explain why you would be so good at this one. And when I get HTML code what is needed for doing the www pages and so on. I have money for 2 students, but if I take 2, it's not full-time work, so it's about the 80%. And so on. No questions, no comments. So also for Matthew, that if you haven't done your internship one already, I could offer a work for 2 months to do it. If you are able to translate Finnish stack questions to English or in Russian, and you understand HTML code. How about the exercises and assignments so far? Do you have any questions about them? Are you still awake?
Yes, I have. Can I ask it?
Yes.
So my question is about the final report, and I want to ask if we need to add something else. So do we need to just compile all the previous reports and change them a little bit, or we need to find some new information? So for example, like we take the first report and we add some grouped variables that we grouped before into that section, and we can just have all the content that we had in previous report, but just compiled in one big report. Is that the task for?
That's the idea. So you can use all the previous ones, but of course you check that it looks like it's doing the same study all the time, so everything is nicely connected. You can add there more analysis if you want, but it's not required anymore.
So is it okay if we just copy paste the text from previous reports?
Yes, if you have no errors in there. So if I have commented on something that is incorrect or something else, of course you correct them. But otherwise, basically, yes.
Okay, thank you very much.
No
it's
problem.
clear for me now.
Good.
Excuse me, I have also 2 questions. One is about the final report, and one is about the curve fitting.
Yeah.
For first one, for the final report, I do a regression on the price. However, the only things that fit to that is like just the price per meters and the year's construction. However, when I do it in the report, small report that I have sent it before, and you give the feedback that the price per meter square is not so good to display it because it's directly calculated from that. So I don't know how to change it, or I just uh, eliminate the price per meter second meter square and keep the only the years construction variables.
Um, the price per square meter is always sold with the original price and the sites. So that is something you know afterwards.
Yes, of course.
Yeah. So if you just think that you are buying a house, you probably know the sites beforehand.
Yes.
I think that would be a little bit better in your regression because you want to do this kind of study before you buy something, so you know is the price reasonable.
Uh, so if I do the regression on the price, what factor that I should include? Because when when it when I do analyze, the only two things that have the significant below 5% is years and uh, price per meter square, and other things is like they
Did you
above.
try all of them?
Yes, the others is above 5%, and some dummy variables that is not allowed in regressions.
Okay, in that case, if I were you, I would put the first analysis where you can show that all the others are non-significant. And of course, you exclude them one by one, not all at the same time. Because when you exclude something, it may make something else to be significant. So just be sure that you exclude them one by one, not at once. And if it still shows that only those are significant, then you add also the last one and say that you did do it by one, and this is what happened.
Oh yes. And one more thing,
Mhm.
my final report is like doing based on like to know how the price variable between things, but there is a kind of a factor that depends the price depends on a lot is the cities where it comes, but like when I do the regressions, it seems not to be significant. I don't know why, or is that like because the big city and the small city is not comes into order.
But you are not allowed to put any categorical variables into the regression just like that.
Oh,
They
yeah.
have to be dummy variables before you put them there.
So I cannot put the cater
Categorical variables, no, no,
yeah, like
no,
city,
yeah, no,
and I cannot put the
yeah, no,
the one
no
that
way.
just have one and zero.
Yeah, yes.
Yes. And another question is about the curve fitting. I have do that, but like I see it's I don't know if I make things too complicated.
Mm-hmm.
Uh, can I share my screen?
Nope.
So I just do it by lock two faces beside the equal size, and it becomes the linear function.
Mm-hmm.
And I start to do the analysis. It comes the line fitting. Is that okay?
Oh, yes. Sounds good.
Yes, thank you.
Anybody else?
Yep, I have a question. It is said that our final report should follow instructions of thesis. And does it mean that we should have an abstract conclusion or stuff like in the thesis?
Yeah.
Yeah, okay, thank you.
So this is your first practice for the thesis. Anything else? Okay. About the timetables, I thought that we have lectures on 12th of April starting at 10 a.m. It's Monday. And because I have a meeting, I asked a timetable to change the starting time till 11:15. So we have the lectures on that day, but they just start 11:15 till 12. So it's a shortened version. Hopefully, at least I got the message that the change is done, so it should be seen also in your timetables tomorrow. But if you're just thinking why, it's because of my timing. Anything else? I had a lot of things in my mind I have to remember to tell you, but at this point I just forgot all of them. Today topic is very, very short. We start doing the numerical derivation, numerical integration, and differential equations. So we have a lectures today. We go through the derivation part. Next week we have lectures on Thursday when we are talking about the integration, and the April 12th. What is the shortened version is the differential equations. And that is the last time I am lecturing anything. So the next 19th of April is just getting all your assignments done. It may be that because this differential equation part is so short, you want to ask something about these, and we can go a little bit more of them. But the 19th and 22nd of April are concentrating on these things. So after that, all the lectures are cancelled because 27th of April I am doing something else already. So actually I am in Tallinn to have my presentation. Numerical derivation, you already know how to do the derivation. You know what is the meaning of derivation. What is the meaning of derivation? Please tell me. What did Heikki tell you about the derivation? Why do we need it?
I think he tells a lot of things, and one of the things is like we need it because there's some function like have to find out the tangent or find out something else.
Okay. Any other ideas? Where do you have used or met the derivation in real life?
In calculation, like
if I say real life, I'm meaning something else but math lectures.
I think it can be used in economical field and medical field, and might be other too.
How in both ways?
In economical field, it has to look at the change in the commodity marginal. Marginal rate of commodity, and in medical field, uh, sensitivity of the medicine to the patients.
How about everyday life? Have you seen it anywhere in the everyday life? How many of you have a driving license?
Me.
And how about any speeding tickets?
No speeding tickets.
So you haven't met the derivation in everyday life?
No.
Thank you. That's good. So, of course, nobody thinks about the derivation at the time. But when you get the speeding ticket, basically for the police, it's enough they see that you have speeded for a while. It doesn't mean they are not concerned what is your average speed. Your average speed from Lappeenranta to Mikkeli may be quite low, but still you can get the speeding ticket. So derivation tells you the instantaneous speed. If we think about you who are studying mechanical engineering, volume, flow, all those things are very basically derivation. So I don't know whether you did talk about this one with the Heikki. But let's see, here is the pipe, and there is, for example, sawdust coming. This is the pile of sawdust. And what you know, there is 2 cubic meters per minute, the sawdust coming. So you know the volume flow, you know the formula of how to get the volume for this one. So with the derivation, you can know at which speed the height of this cone is increasing, and so on. So basically, you use derivation quite often, but you just don't think about it as a derivation. And here we concentrate on how to get the derivatives if you just have the data. So you have done the measurements in the laboratory or something like that, and you still should know the derivatives, speeds, and so on. You do not know the function, but you know the value, so you have to be able to solve them. A numerical derivation is actually the easiest derivation you can do. Hopefully you see the formula right now. So this is the definition for the derivatives. And because I haven't thought this goes for you. I hope Heike did go this one through for you. But if we want to get rid of this limit sign and we have only this part, there is some kind of error because this and this part is not exactly the same. And if this one is connected to the 8s, it's almost 0. So we basically can get rid of it like it's done here later. But if we do not have a limit, we can have the left side, we can have this rightmost side, and where is the equation? So we can solve it like the equation. We can multiply with 8s, and then we can reform this one. So in this case, we see that if we know the value of function at this point, and we know the step size, so we call this 8 as a step size, and we have the idea of the derivatives, we can get the next value. But if you have done the measurements, you know this one, you know this one, so you can use them to solve the derivative. So basically, if you just exclude this part here, this tells you what is the numerical approximation for the derivative, because we always assume this is very close to 0, so it's not affecting very much. We talk about that it's a forward difference if we use this value and the value after that, and we talk about backward difference if we use this value and the value before that one. That is the only difference. What we do, we can also have this called central method, central difference. If we combine these two, so we basically want to have a derivative at this point. So we use the value after and the value before, and now the step size is 2 times 8, because between this and this it's 8, between this and this it's 8, so altogether 2 8s. So these are these easy formulas for solving derivatives when you have numerical values. So here you can see some graphs. Like see, this is the actual derivative at this point. And if we use the numerical form, we use this value, we use this value. So our approximation is basically quite far away from the original one. The same thing for the backward. So it's a little bit different, but still it's not exactly the same as the original. If we use the central form, like done here, it doesn't mean it's exactly the same as the true derivative, but it is usually closer to the correct derivative than 2 of these. So this is just to give you some idea how good your derivatives are. Any questions so far? And here is the table. So you have the first derivative, you have the second derivative, and you have the third and fourth derivative. How many of you knows what is actually meaning of a third derivative? What is the meaning of first derivative? So if a function is, for example, distance, what is the first derivative?
Velocity.
Yes. And the second derivative?
Acceleration.
Third? Nobody knows. Now I have to say I don't remember the word even in Finnish, but you can ask Seppo for this one. The third derivative is basically the same as, just think about the elevator is starting to go up. The feeling you have in your stomach, if it's done starts quite fast. So basically that is the third derivative. And actually in mechanical engineering, it's needed quite a lot if you continue studies further in this field. Basically, if you have applied exercise, how do you recognize that there is a derivation concerned, and what kind of derivation? You basically answered the question already. So if you have the unit meters per second, you already know that it has to be erase. It has to be a derivative of distance per time. If you have meters per second squared, it's a derivative of a distance, and per time twice. This one can also be thought as speed divided by time, so it could be derivative of a velocity over the time. So the unit tells you what is derivated by what and how many times. So you can use this one in applied exercises. Of course, it cannot be the average case because derivative is always about what happens right now or at that particular time. So it's not average. So you can use these formulas just to get the derivatives in different cases. And here is one example. There is the x values given, there is the sine values given, and then is asked what is the derivative at point 1.76. And what we need to know is the step signs. A difference between these two is 0.02. So this is our aids in the definition of derivation. And then if you just want to check what is the first derivative and you use the forward method, you just follow this one. Where is the value at this particular point? 4 times the value after that, minus value even after that. And that is divided by 8. Please remember that these formulas are a little bit in different form than the formulas I gave there, because the delta x's are defined here a little bit differently. But you see what is got with forward, what is with the backward, and with the central. And in this case, because this is symmetrical case, the accurate and the central method gives exactly the same, but not the forward or backward case gives a bad approximation. So all the approximations are quite good. This just tells you what is the maximum error in these cases. And it's not same as a delta x squared, because there is this odd sign before. It is just connected to this one. So actual error formulas are not given to you. So your next assignment is quite easy. You just had to follow these formulas to get the results. Any questions? If no, I stop sharing and I take your course here and open the next assignment for you. So the numerical derivation assignment is opened and it should be returned 15th of April at the latest. And if anyone is actually interested in working with the stack exercises, just send me email and we can continue discussing.
Paivi,
Yes.
can I show me my final report? Yeah, I want to get some suggestion. Yeah, before final submission, so I have almost prepared.
Yes, I opened the breakout room, so
thanks.
you can come there.
Okay. I will. Okay. Measurement mathematics reports. So try. Yeah, can you see my
Prakash, while inviting
Prakash.
you breakout
Okay.
room.
Yeah, you need to go to breakout room.
Yes, okay.